Inequalities. We've looked at inequalities before. We didn't do it, I don't feel like we did much of it before, but we introduced this to you way back in grade 9, where something is less than or greater than, right? So the little alligator eating the little mouse. So x is less than 3, right? We now have set notation and interval notation. We have two different types. Make sure you know the words, right? So if I say set notation, then you write it in set notation with the little curly brackets. If I say interval notation, you write it in interval notation. Don't forget the little x as an element, right? Because I want that saying what variable it is. I prefer interval notation, so we're going to do interval notation unless I say otherwise. So on the test evaluation, if we say set, do set. If we say interval, do interval. If I don't say, then I prefer interval. Okay, so then just do interval as kind of a default. Inequalities. Inequalities is where things are less than, greater than, less than or equal, greater than or equal. That's an inequality, right? It's similar to an equation, and you solve it the same way you would solve a linear equation. So an inequality holds the same sort of properties that we do with an equation, except, right? So except, we treat it the same way as an equation, except if you multiply or divide by a negative number. If you multiply or divide by a negative number, you have to reverse the inequality sign. So if it's less than, it becomes greater. If it's less than or equal, it becomes greater than or equal. So we reverse it. We switch the direction. And that says to preserve the validity, that's us trying to sound fancy, of the inequality. Validity means that we want to keep it true. We want to keep it true, okay? We want to keep it correct, right? So validity means to keep it correct. What that means is that when we were doing number lines, so way before when we were doing number lines, we know that there's a left side of a number line and a right side of a number line. We usually have the 0 there. So if I said to you 62 and I multiply it by negative, it would flip it to the negative side of the world, right? It's like the underworld or whichever one you want to take, the negative side there. So it was a big number, but now it's a big small number. Right? So when you're switching from a negative to a positive, you're switching sides of the number line. And it switches the direction of which, it switches the direction of the inequality because you're switching the meaning of that. Right? So when I would say, and we introduced this to you before way back in grade 9, I would say, is 2, so let me start you with the little example I would show you. I would say, okay, is 2 less than, negative 2 less than 6? It doesn't matter if they're negatives or positives. It just works the same way. True? Right? That's valid. So validity of that is true. Negative 2 is less than 6. Now, can I add 3 to both sides? So add 3, so that'll be plus 3 plus 3. So that's 1 is less than 9. Is that still true? Yes. Can I subtract 5 from both sides? Negative 4 less than 4. Good? Still true. All valid, right? Valid, keeping the validity. Can I divide both sides by negative? If I divide both sides by negative, so I did all these operations, it still keeps it valid, right? The validity of it. If I divide this, that becomes a positive 4. This becomes a negative 4. Is this still a valid statement? No, because I've switched the sides of the number line. And when you switch the sides of the number line, a bigger negative number is actually a smaller number versus a positive number, right? So this was a big number. When you switch it, now it's a very little number. So by multiplying, does the same thing hold true? So again, try it again. So if I go 3 is less than 7. If I multiply both sides by negative, say 2, can I multiply both sides by a negative? That makes it negative 6, and that's negative 14. Is that true? No, because now it should be the other way. So multiplying by a negative or dividing by a negative switches which side of the number line you're on, so therefore this needs to flip in order to stay valid. They don't say equal because they can't say equal. It's not equal anymore. It's valid to keep it a valid statement, a true statement. Okay, so that was what we learned way back in grade 9. When you multiplied or divided by a negative. How often do we multiply by a negative number? Not often. Usually when we get an answer, we would get something like this. We would say negative x is less than 7, and most people, the instinct is to divide both sides by negative 1. So that's what we would do. We don't usually multiply by negative 1, but you could. Okay, so it works either way, but that's what we're saying, is that when you're solving, if you do this, then now x has to, this flips, and it becomes this, to keep the statement valid, the validity, which is true, to keep the statement true. Okay, so again, refresher of inequalities, we got that. So let's go through, just again, a little bit of grade 9 review. So when we have this, we would bring, it works the same way as an equation, except for that last statement when I divide by a negative. So if I divide by a negative. So here, bring the 4 over, just like normal. So negative x is less than or equal, that would be 27. Right, becomes positive 4. Divide both sides by negative 1. You don't have to show this, but you can, right? And then when I do this, this will flip the sign. I'm going to go, instead of less than or equal, it's greater than or equal. So this, that's the important part there, and it's now negative 27. Okay, so whenever you divide by a negative, it usually only occurs on that last statement, the last step here, when we're going from this step to that step. It doesn't happen like all the time, but when you do a division or multiplication by a negative, it flips. Is that okay? So here, do I need to do it here? No, it doesn't always happen. So less than, that becomes 15. Divide both sides by 5. You don't have to show this division, but if you want to, you can. And so x is less than 3. So you're not always changing the direction, right? Just when you want to. Just kidding. When you need to. Okay? So you only do it here when you have to because you're dividing by. Okay? Over here, when we divide by the negative 7, right? So when we divide by a negative, to get the x by itself, I need you to go, I have to change that direction. So instead of less than or equal, it's greater than or equal to negative 2. There. Sorry, the marker got a bit dirty there. Okay, so right there. Make sense? Okay. So then over here, we've got light slightly longer. We would say bring a couple things over. So you can bring over each way. So I'm going to bring the 2x here because there's 2x's there and then the 27 there. It's linear solving. It's up to you, right? So it's going to be 3 minus the 27, so negative 24 is greater than or equal. This is negative 4x minus 2x. You can go faster, of course. When you're doing linear solving. Dividing both sides by negative 6, I created it by bringing it here. If you could have had it the other way and you would have the same answer. That's fine. So you'd have 6x here and the 24 here, and you wouldn't have to divide. But your answer would be the opposite. So you would get still the same answer. So divide both sides by negative 6, and I would get 4 is less than or equal to x, like this. Okay. Or would you get the same answer if I brought the x's over there? Yes, you would. Okay, you would have done this. You would have said, okay, I brought the x's here. So 2x plus 5x, 7. And then you brought this over, so it'll be 6x. And it would have been like this. Okay? And then people go, is that the same answer? Yes. You divide both sides by 6. X is still greater than or equal to 4. When I read these two statements, I read from the x. I go x is greater than or equal to 4. From here, x is greater than or equal to 4. Right? So again, look. X is greater than the mouse, right? X is greater than or equal to 4. X is greater than or equal to 4. Those are the same answer. Okay, so it doesn't matter which side. You've got the same answer. It doesn't matter. Okay. So then, just to remind you, linear equations have one solution, right? They would have x equals 2. That's my answer. Linear inequalities have many solutions. Anything less than 2 works. So this is saying x is less than 2. So when I give you this answer, I say x is greater than or equal to 4. My answer could be 5, 7, 102.4, 4.0001. Anything greater than 4, right? There's many multiple answers. For an inequality, for an equation, it's a single answer. Right? So this is many answers, single answer. All right, what else do we need to know? Number lines. A number line, I can't remember if we did number lines in grade 9. Oh, we did. Yes, we did, right? So we do open dot, solid dot. Yes, we started that in there. So number lines, just to refresh your memory, you've got open dot, Okay, if you're like, ooh, what's that mean again? Open dot, we know that. So open like that. If I said x is less than 2, you do 2. And then less than, I usually told my students just do a line slightly above it, like a double line, and then put an arrow to show me where it is. Okay. If it's a solid dot, that means, right, included versus excluded. So this would be solid dot. On 2, make sure you label the number, and it's less than or equal to 2. So again, I would do this with an arrow. Okay, so open versus solid. Good. All right. And we always want to check your answer in the original. We'll do this later. So you check in the original. I'll show you how to do that in one of the examples we do today. So check in the original. The reason why is because anywhere here, anywhere that you wrote in the marker, I wrote in the marker there, I could have made a mistake. Right? I could have lost a negative, forgot a 2. So when you check your answer, just like we told you before, always check in the original one that I typed. Okay, so go back to the original, because that one, I typed it, that's our original question. Don't check it in anything you wrote. Right? So I'll show you that in another example that we do. I want fraction form for this whole chapter, right? So we're going to go fraction form forever from now on, right? So fraction form, unless I ask for decimal. So if I say specifically to decimal, then fractions. All right, now let's start some new stuff. So that was a little bit of a refresher. We're going to start a new concept. So now we've got a new concept, and it's called end. It's the end inequality. The end inequality means that it is this and that. End in math is very, very, very specific. It's different than in kind of the English language. We go and and or kind of interchangeably, right? And for math means at the same time. So this means at the same time. I want both of the things happening at the same time. So and. Okay? So that can be stated like this. So we've seen this before, right? We did domain and range. So this is telling me, I read from the x. I start from the x. X is greater than or equal to 2. And x is less than 5. People would say it's between 2 and 5, right? Which is fine. But we're now going to learn an inequality with end, which is changes things a little bit. Okay, so that's like this. This is saying, this is also the same way of saying x is greater than or equal to 2 and less than 5, right? So people say it's between that, but it can also be stated as an and statement. So that and statement is at the same time. So we're this and that. Now, you might be going, well, what's the difference? I will show you what the difference is. So I'm going to show you, I tend to do a little bubble over here. So I'm going to do a little bubble, which you don't have to show, and I'll do my answer over here. So we're going to do my answer. So I'm going to go, my bubble is my head thinking this. Okay, so I'm going to do this. Little bubble. So this is saying it's between between positive 2 equal to it and 5. When I write it this way, this is what this is saying. It's the same as this. So it's saying x is greater than or equal to 2, so solid dot on 2, greater than or equal to 2. So I do that as one statement, and then I'll show you how to put it together. Greater than, it goes this way. You don't have to do it with a ruler. I'm doing it with a ruler just to make sure it's neat for you. When you're doing rough, do it fast. Okay, so it's from here to the right. And x is less than 5. I'm going to use a light blue. Tell me if you can't see it, but for this one, 5. So I want 5, open, 5, and less than. So I'm going to raise my line kind of up here, like that. Can you tell me when you can see the light blue and the purple at the same time? That is a double line, which is here. Does that make sense? You see the blue and the purple at the same time. So and means at the same time. That's why we know it's between the 2 and the 5. So my actual number line answer would look like this. That's why together it would be solid 2 open 5, and it's between it. So this and statement, and what I'm going to do is I will give you sometimes like this, and I'll sometimes give you this, but you have to know that they're equivalent. Okay, so this is saying greater than or equal to 2 and less than 5 at the same time. So I mean double, which is between the two. How come when the lines are overlapping, that's open and that's a line, but they're not both solid there, so that's why it stays open. In order for that to become solid, I need solid, solid dot. So see solid dot, solid line? That's why it stays solid. This is not 5, so you can't equal 5. So even though 2 is overlapping, but they're both not equal to 5, so I leave it open. Okay, I need both of them, and, so double. Double lines is what and means. Okay, so that's and. So try it again. Let's think of that and statement again. So this one here says, I want less than, so again, I like to draw a little, right, to picture it. I do it quick, and again, you don't have to do this with ruler. If you're doing this on a test, do fast. We want to go less than or equal to 3. So solid, I do the dots first. So I do -1 and 3, okay? Do my dots. Less than or equal to 3, which means left, like that. So do it fast. Less than -1. Oh, less than -1. Less than -1 would be this way, also pointing left. I want to know when you're going to get the purple and the blue line at the same time, the double line. Where are you going to get the double line? Yep. Anytime here. So my double line occurs this way, only there. Not between it, but to the side. So not everything is going to be between anymore, right? Not everything is between, right? So that's kind of going to be different. So this is what we're adding to our inequalities this year. So and inequality means you're looking for the overlap. This overlap. Now, one more time. So I was saying the open closed, and you're like, not sure if I got that. Here, if I say and it has to be both at the same time. If this is open and that's a line passing through it, are they both, is it solid or open? For here, solid or open? Open. They're not both happening at the same time. If it was a solid with a line, yes, that's okay. So my answer for this one is actually going to be, my answer will be open -1 and to the left, because I need both of them to be happening at the same time. Not, this one isn't happening at -1, so I can't make it solid. I know the line is passing through -1, but because they're both not happening, it remains open. And then if I wanted to write this down, it would actually be x is less than -1, right? So that's what this is saying. These two is actually saying this altogether. Do I have to write it in set notation, etc.? Yes, I will. I'll fix that in the next page. Okay, so I'm going to say now our answers, we want to write them properly. Yes?
So for your final answer, the only graph towards the double line?
This, yes, exactly. So that's why. So some people don't picture it. They kind of picture in their head and they graph that. And some people go, okay, I need to draw something and do a quick drawing every time. Yeah. And I'll tell you if I want you to graphically show it or if I want you to do set notation or interval notation and that sort of thing. Okay, so on the next page we'll practice how to answer it, but this is the theory. Does that make sense? Yeah, so we want where the double lines are, and that's my answer. Okay, I'm going to pause the